네, 감사합니다. 안녕하세요. So, hi. Hi. My name's James. James Paudali. But if you want, you can call me by the same name my students refer to me, which is Karu. Karu 선생님, Karu Sam. And I'm a school teacher. I teach at Hongik University. And I teach in the Visual Communication Design Department. So I'm pretty sure, I teach some of the best young designers in Korea. And I don't often say it, but I do want them to know, if they're out there listening anywhere, you know, you're my friends, you're my family. Now sometimes you're even my coworkers. So, 감사합니다. Okay, so I think I understood media artist. Media artist. I'm a media artist. I'm often referred to as a media artist. And that title's okay with me, and I think I understand what it means. I tend to just say I make things with computers. Sometimes it's engineering, sometimes it's design. I've been given the advice by my hyung that I should say it's art in Korea because that costs more money. And I acknowledge that something about what I'm trying to do is like what media artists have traditionally tried to do, which is deal with a relationship between human beings and machines and how they interrelate with each other in this act of being creative somehow. This famous example of Stellark. But I haven't always been a media artist. At some point I was just a little eggy, and then I got older, and then eventually I started playing guitar in a rock band and skateboarding. And those two things contributed a large part, I think, to the kind of style and ethos of my work ever since. Those elements of kind of punk rock and do-it-yourself, and a little bit of misbehaving, or doing what you're not told. But before I lived in Korea, I worked here, on the planet Mars. I mean, obviously I didn't work on the planet Mars. I worked at a company called Honeybee Robotics, which was a quite small but very up-and-coming robotics company located in Manhattan. And they specialized in a particular type of product, which was robotic drilling systems for the exploration of other planets. So we got to make a lot of cool projects. Some of them are still on the planet Mars. This one, the Phoenix lander, just completed its mission and discovered little chips of ice in the polar caps of Mars. But I spent most of my time working on the Mars Exploration Rover. And we didn't make the kind of cool robot head part or the wheels or even the arm. We just made this, the rock abrasion tool. I thought it was a really rewarding project and also had a really important goal, because on Mars, as you drill down into the surface, you drill deeply into the past. So we look at the past history of Mars, perhaps we find something about the future of planet Earth. That's the idea, at least. But I couldn't trick people into thinking that I was a good enough engineer to be working for NASA for that long. So eventually, I retired. And I got a residency at a place called I-Beam. I-Beam is an art and technology center, also located right in the heart of Manhattan. And I got a fellowship in this lab called the Open Lab. And the Open Lab was started by a guy named Jonah Peretti, and another man named Mike Fruman. And the idea was that if you put artists in a high-tech production lab and said, you can do anything you want, maybe interesting things would happen. But there was one rule. That's that your work had to be completely open source. So no copyrights, no intellectual property. We had to share what we made. And so we did. But I guess that's enough about my history. I'm called here today to talk to you guys about, technology. Beautiful technology, innovative products and gadgets and things that will change our world. And I wanted to talk to you about those products that I think really bring us all together, join the world in unison. For me, the most important one is the screw. NASA. I mean, obviously this is a tool that we've all used. We can all appreciate on some level. It's in something we all own right now. It's a robust design, tested by time, simple API, easy interface. It has a lot of standards, and we kind of all know them intuitively, can find them quite commonly. And then it also has a lot of varieties. There's metal, for wood, long, short, different materials. And then it lasts. It keeps working for a long time. Whoever designed the screw originally put a lot of thought into making it, you know, something that wouldn't break after the 2-year after-service plan. And so I started thinking about, like, you know, we talk a lot about IT technology and the internet as a very important sort of landmark moment in our history. And I was thinking, I started adding up some sort of made-up numbers I found on the internet. You know, there's maybe like 600 million daily computer users or casual users, and then you have maybe 55 million servers, something like that. I took apart my computer and I counted all the screws. I used that as an average, and I figured out maybe there's something like 12 billion screws in the internet. So that's more than users, that's more than servers, that's more than personal computers. That's a lot. I mean, it may be the most prevalent thing on the internet other than porn and Viagra ads. But, you know, the screw has just lost its glamour. It's not celebrity design anymore, you know? And it's a part of a class of products or technologies which have stopped seeming like technologies and have just become kind of a part of the environment, like boats. I mean, it is boats that are most responsible for the globalization of the world. I mean, they transport the products that we make from one place to the other, more than airplanes do, for certain. Bicycles, you know, a highly conservationist technology, affordable, easy to maintain, easy to learn to use over the age of 5 or something. Corrugated iron. Most human beings on this earth live in a corrugated iron house. Most of them. Probably not any of us. Maybe some of us. But not too many of us. But most of the planet. The planet's not really well represented sometimes in forums like these. And then AK-47. It's the #1 tool for handling our disagreements on a global scale. And a much more deadly weapon than the nuclear bomb has ever been, or any number of smart new technologies. So, I mean, what I like about these technologies is that they service more than just this half of the world. And much of my career has been in creating tools that service just this half of the earth. But what I'm trying to do is I'm trying to take a change and start making things that are still media art, but that somehow service, you know, the other side of the planet. The other side being a metaphor. There's other sides everywhere. And this is a good time, I think, for artists and anyone in general to start trying to figure out ways to create designs to resolve human problems, to serve human needs, because we're having a crisis era. We've all heard about this financial crisis, but this is kind of just, you know, the cherry on top of a crisis ice cream sundae that's been building and building over the last, you know, century or so. I mean, right now, diseases are emerging at epic rates. Over-urbanization. Cities house more human beings than anywhere else now. More human beings have moved to the city than live outside the city. So we're more and more crammed together. And obviously, I am not saying anything a Korean doesn't already know. Poverty. Most of the world lives on under $2 per day. Most of that half lives on less than $1 a day. So we're quite poor. And we live in quite meager, inadequate housing. And if you were to stand looking back 9,000 years to the very first civilization in Catalhayuk, at the mud and adobe houses that were being made there, for some human beings, that's a more attractive house than they see today. Pollution, obviously, global warming, we don't even hear about it anymore. It's not because it's solved, it's just because it's boring. Extinction. I mean, we worry, right, that we may be extinct. People like Stephen Hawking say, you know, we have to get off this planet. we got to get out of here because we're going to be extinct. But a lot of biologists say we've already entered an extinction phase. And then this city and this world that we're all sharing, you know, sort of arm in arm, fighting against all these different, you know, deadly problems all around us, is slowly feeling less and less representative of the majority of all of us, as it's being owned by smaller and smaller numbers of people and being commercialized in a way that it doesn't feel like our place, it doesn't look like our city, and we have no voice in it. Add to that war, terrorism, and this kind of age-old business. It's a pretty bleak picture. You know, so, you know, here I am, kind of, I guess, aware or feeling aware of this fact. And I've decided to be an artist. That's not the most, like, helpful job you could do. I think it probably isn't. But I do think there's a role for artists. And by the way, I'm going to use the word artist and designer pretty much interchangeably, and engineer, and a lot of other things. But I do think there's a job for us. At least I've decided to take a job. I think my job as an artist, as a designer, is to be a good friend and a critic, an honest critic who would say to their friend, hey, what you're doing right now, that's a bad idea. You need to stop immediately because you're going to get hurt and you're going to get us all hurt. And I think the artist has a good chance to be that critical voice without sort of breaking the feathers of a daily routine of life. And a media artist especially can be someone who can look at the technological solutions that other engineers are proposing and say, wait a second, that could go wrong. That could go wrong, I think. You should try something else. You know? So we sometimes have to walk down a dangerous road in front of everybody else, you know, intentionally exaggerating some situation in order to reveal the danger that, you know, could happen for the rest of the world if they followed. You know? And if we do this, and we tell people, wait, stop now, don't do this, maybe we could prevent a situation where we're beyond the point of turning back, where we're kind of stuck with our destiny. And then it's not super bleak in that beyond that, when problems start getting solved, and designers stop being celebrities and start addressing human needs, then designers can go back to doing all sorts of things, quite interesting things, I think. Because once we've realized we've hit rock bottom, there's nowhere to go below, we only have up, then we can start doing some of the things that curator Paola Antonelli talks about when she says designers can expand our mind and allow us to sort of adjust to the future, which is going to be radically different than the present, and hopefully positive as well. And on top of that, it gets a little bit boring, so you always need artists to kind of make things a little lighter. So I want to tell you about a project that I was involved in for about 5 years of my life that I think does some of these things and fails in some other ways, but it's certainly not too boring, I hope. It's called the Graffiti Research Lab. And it was a marriage between myself and another young man, we were young at the time, named Evan Roth. And Evan was a student at Parsons while I was working as a roboticist. And during that time, he was interested in graffiti through digital technology. So he was projecting graffiti artist's tag in the city, and he was looking at graffiti as data to be manipulated. And so we joined together. He knew some graphic design and some computer programming. I knew a little bit about electrical engineering and hardware making. And we thought, between the two of us, we could do some interesting things. So we formed this research lab called Graffiti Research Lab. We wanted to make technologies for criminals. But these criminals to us were kind of like super cool guys, you know? They were like the James Bond characters that always had the mission, didn't care what anyone else said, stepped into the scene, shot everybody up, got the girl, got away. That wasn't us, you know? We were in our 30s, we were otaku computer programmers who really liked the internet. So we thought we could be that old man. You know, James Bond has that old man, Q Branch, who's like, I'd like to make you a tool. Don't break it, Bond. You know, that guy. We wanted to be this guy. And we would make these technologies for graffiti artists, and then they could use them in the process of their normal work. So, sometimes it took the form of stencils, sometimes it took the form of traditional graffiti, but we used conductive paint instead of normal paint, and electronics and LEDs and things. We also continued to project things in public space, and we tried to find ways to capture graffiti artists' tags. And then we started to incorporate or steal technology from advertisers and from city municipal signage and things. So we were using LEDs and lit up signs so that graffiti could kind of compete during the nighttime. And we would do this on the street, and we would do this in art shows, and we would always make movies of it. So we would document everything we made, and we would kind of put these into little movie clips and put them on the internet. So I wanted to show you guys one clip of a project that, well, I think it's safe to say is the simplest new media art project in human history. It's called the LED Throwaways. So LED throwaway is an LED, a battery, a magnet, and a piece of tape. You put those together in a not very scientific way, and then you can throw them, and they stick on metal surfaces. So the first time we did it, we thought, that would be kind of annoying to take down. So it was sort of fun in that sort of cruel way. But then we thought it would be more interesting if we got more LEDs and more people. So we made maybe 300 LEDs. We told 6 of our students, yeah, you're coming with us. And they came with us, and we started throwing them on a museum that was close to I-beam in the east side of Manhattan. And it looked pretty much like you'd expect, kind of turned the building into a Christmas tree. But what was interesting was the social response. So people were walking by on the street, looking at us, and they'd stop, and then they'd come over and see, well, it's a magnet, and it's technology, so it can't be against the law. It has to be kind of appropriate, because it's technology, right? So they would take it off, and they'd throw it back up on, you know? And we watched this happen over and over and over again in cities all over the world. People ranging from little kids to graffiti artists to, adults from Texas visiting New York City for the first time. They would take this LED and they would throw it on something, and just for a second, they had one little star that they had contributed in the city that really didn't have anything to do with them, a world they hadn't made, that they couldn't control, that they owned no part of. They could put one speck into it and stand back and look at it, even if the battery would die. So this was a fun project, and we did it pretty much until it was just so boring we couldn't take it anymore. Another project that we worked on was called laser tag. It was a little bit more technologically advanced. It required a projector. Those used to be quite crazy for someone to own a projector, but now, we own projectors maybe in our school, we have access, or in our church, or a lot of people have them as their home theater system. So it takes a projector and a camera. Cameras are everywhere. I see some of you are even pointing them at the stage right now. But CCTV cameras are in our city all around us. So just borrow one of those for a few minutes. And then you need a laser pointer. And probably someone has used a laser pointer today in their presentations. So these are pretty common, right? And then you need software. So what we did was we wrote that software. And it allowed someone, graffiti writers for us, to go and draw on the side of a building on the same scale that only usually advertisers and property owners can operate at. Skyscraper scale. And so people did this. We started out doing it with the graffiti writers, and they made quite beautiful aesthetic work. And then we put this into other people's hands, activists, and they said very provocative things like, don't build this here, or I don't believe in this politician or something. And then we gave it to normal people, and they said, I love my mom, I want to marry you, this type of thing. But universally for people, they felt a kind of release and a kind of empowerment by being able to create their own words on the face of the city. So We've done this project all over the world now. And every place, there's one thing I'm most amazed at. It's how little we know what's going to happen before it happens. Because we would make these projects and have really no idea other than, that's cool. And we would take this thing that we thought, that's cool, and we put it in someone's hand, and they would do things that sometimes weren't cool. Sometimes were really politically complicated, or provocative, or very personal, or very technically hard to do. And we felt more like research scientists. We had this piece of equipment, and it was kind of our tool. And each city was a different sort of control group. And we could see how citizens in that city and the actual buildings themselves would, interact compared to one another. So it was quite an education in dynamics. And also quite fun for us for years and years. We no longer do this anymore, but you can still find it. In fact, most people never saw it. People usually just saw it on the internet. And a lot of people saw it on the internet. And so we thought, wow, we're getting internet famous. And we did, but somehow internet famous doesn't mean you make any money. But it could also be that anytime we made any money, we just laser cut them into business cards. But what we did do was we released all the instructions for how to make these projects. We released them out on the internet. And so people could, if they wanted, imitate us. And they did. But they didn't just imitate us. They modified what we did. They improved upon it. So their LED throwaways were more complicated than our LED throwaways. They did more interesting things with LED throwaways than we did. And they would share how to make those. And that kept growing. And more people made things, including famous people who invented the wiki, and also crazy people who did things that probably shouldn't have been done. And artists who we really respected who started using LED throwaways to make their own work, and then protesters who did things that got them thrown in prison in foreign countries, and then business people who started selling it because, it's open source, so we couldn't restrict them. We just wanted to be artists, but accidentally we had become like an economic stimulus plan for the LED industry on a global scale. And then sometimes advertisers wanted to do exactly what we did. But when they did, crazy things happened. Like people thought they were bombs and they got arrested and people went to jail and had to pay millions of dollars in fines. So it was a quite chaotic, strange time. And it's so much so that the word throwaway became a New York Times buzzword of the year in 2008, which would make us feel really good, except we did the project in 2006. But what was really nice is that you can still go on the internet, you can go on Flickr or Dom or whatever, and you can look at images of just normal people who are using LED throwaways for something, advertising their soccer team or for throwing rice at their wedding. We do this in Western traditions. And then advertising, products or advertising themselves to their loved one. And sometimes they made things that were just more beautiful than we did. Just more artistic than we did, and we felt quite good about it. So we did the same thing with laser tag. We released all the software online, and it happened again. People started to imitate it. They started to do it themselves on their own, and advertisers also did it on their own. But what was so cool was that we would do a show at a museum, like the Tate Modern, where we would draw with our laser pointer, and it would take a crew of like 20 technicians and permission from 10 curators, and it was all very structured and felt kind of boring. And then the next weekend, someone would write me on Facebook saying, "Hi, I'm an 18-year-old student at Queensmary College in London, and I did laser tag all by myself, just like you guys." So it was wonderful. And we did it in Korea as well. But we weren't the first people to do it in Korea. Protesters had already been using laser tag in Seoul before I'd ever come here. Before we had ever stepped foot in the country. They were already using it. I didn't speak any Korean at the time. I don't know what they wrote, but I imagine it wasn't very nice to somebody. So we would make a bike to carry our equipment. We would tell people how to make that bike, and then they would duplicate that bike in their own way, in some other way. And eventually we became a little bit, it felt like, Al-Qaeda. I'm not in Al-Qaeda. But we became a little bit like Al-Qaeda in that they have little separate cells all over the world, and they don't really organize together, but they share the same name, and they share similar goals. And so Graffiti Research Lab Vienna started up, and then Graffiti Research Lab Mexico, and then Graffiti Research Lab Brazil, and then Tokyo, and then Canada, 4 of them, and Australia, 3 of them, and they just started popping up everywhere. And today, Evan and I no longer do any Graffiti Research Lab projects anywhere, but the Graffiti Research Lab has shows all over the world, in Germany, in the United States, in Canada, Houston, Texas, Alabama. Really? Alabama? So we thought this is interesting. This kind of works. This idea of sharing your ideas with a group of similar-minded people seems to promote a lot of sharing and mutual participation. But not everyone likes graffiti. In fact, some people hate graffiti. Some reasonable people don't like graffiti. So we thought, why not do something different, not just graffiti, but use the same principles? So the Fat Lab was born. Free art and technology. The Fat Lab is dedicated to this idea of creative technology of any type, on the web or off the web, graffiti or not, do it yourself at home, electronics, provocative political stuff, software, whatever you want, as long as it's free. And so we thought what the open source movement lacks is kind of like cool factor. I mean, I think it's cool to write open source operating systems. I really do. That's why I'm no fun to go to the club with. But, the world needs people who are doing cool things with open source technology. Like the American Idol of open source technology. Like the MTV music video of open source technology. So we try to make projects that existed in that middle section of the Venn diagram between pop and, otaku. And we had plenty of heroes. The type of projects we did range from imitating the Google car to making plugins that block Justin Bieber from the internet. But the project that probably, for me, most resembled the style of work I wanted to do was when a music video director asked us, they wanted to use that Matrix effect. The one where Keanu's like, wah, 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 and the bullets are over the head. But it cost $100,000 a day, il ok, just to use it, per day, il ok. And they were like, we really don't have il ok per day. So instead, we discovered that if you just put together a little bit of money, you can make a whole a whole Matrix camera rig for just $5,000. So just, Obek Manan, you can make it yourself and you can own it. So we did that for them. This was the type of work we did. The Fat Lab is spread now too. So there's members in Berlin, there's members in Mexico, there's members in Sweden, there's members in Japan, members all over the world. Same principle. Then I moved to Seoul, and I was just a school teacher and stuff. And it's perfectly happy for me. I really enjoyed it. But at some point, I started getting that bug again to make things, And I'd already done a bunch of different things, make fun of people, make fun of other people, make fun of a lot of other people in different ways. And I thought, I want to be a designer for once, I want to design stuff that other people like. So I met this brilliant young woman named Sun Eun-jung, and we started a company called NASA Gongjang. NASA factory, screw factory. NASA, screw. It's all the things that everyone likes NASA. I like screws. So we do a lot of different type of work. We think of ourselves as kind of an idea company. We generate ideas. But then we also have skills so we can make prototypes of things too. And the prototypes range, but usually they have some sort of substantial meaning to us. So one of them is this project here. Anyone know yochijib? Yochijib? If you know what a yochijib is, I know how old you are. A yochijib. You don't see them around Korea anymore, but you used to be able to take the yochi insect. Am I saying that right? Yochi? And you'd stick it inside this barley-shaped helical container, and it would kind of fly around and make sound. So it was kind of a relaxing ambient noise device. But it was also just to play. Young kids would make them so they could play around in the dirt. And we thought, wouldn't it be cool if you had a yochi noribang. So you had a bunch of yochi jib, and the yochi jib could all sing together. So you would start singing, and the yochi would sing along with you, or they could sing other songs, you know, shots, but like yochi singing it. So this is the kind of stuff we make. We actually make these things. And then we also just do commercial work. So we're working with an architecture firm right now to make a project in a club opening up in Gangnam called Octagon. We still try to make things that are innovative in some way, you know? So there's a group of people that we work with quite frequently, a company called Urbantainer. And when we work together, we call ourselves Urbantainer Media Lab. And we did some interesting projects that I think are kind of an expression of the type of things I want to do in the future. It was at an event called the Creators Project. And we wanted to just, you know, be designers and make stuff that was like design work. And so the light bulb is just a beautiful design, you know? But we could imagine it being a little different. So we imagined that, so then we had to make it by making a silicone light bulb. You know, also we were all so fascinated with jib. We loved it so much, and we loved working with local craftspeople. So we made the classic cliche of media art, which is the LED cube. But we made it out of chunggu, normal light bulbs, and jib. So it looked a little something like this. It's a great material, totally economically friendly. You know, it's upcycling. It's a waste material that you turn into usable material. And you can make armor out of it. You can make an LED cube out of it. It's very conservationist. So moving right along. The last project I want to talk about is, well, it's what some of you guys might have heard about when you read the advertisements for this show. But I want to tell you first about a guy that I think is a brilliant man. This is this guy, George Washington Carver. In the United States, it's a pretty household name, George Washington Carver. He was a slave. He was sold for the price of a sick horse. This thing used to happen in the United States. But by the time the end of his life, he was a kyosu, he was a professor at the most prestigious university for black people in America. At that time, blacks and whites did not go to school together. And he most famously invented 300 uses for the peanut. So he was an agricultural scientist. None of his uses of peanut were products. He didn't make peanut butter. 300 uses and none of it peanut butter. What he made peanuts for was because poor black farmers were growing crops like corn and cotton, and it was depleting the richness of the soil. So he thought, let's find a plant that we could plant into the ground as a rotation crop and put more richness back into the soil so they could grow their corn again. And so he did. And you could also use these peanuts, the peanut oil, as a heating oil, as cooking oil, as some lubricant for leather, as a facial moisturizer. So these are appropriate uses of technology. DIY, a low-cost alternative, a socially centered. You can find examples of this all over the world. This is one of my favorites. It's a trowel for planting crops, but it's designed for a certain type of small Mexican pony. Because you can't put the normal big one on the small Mexican pony. It's too big, you know? And so they made this a little one out of local materials, a design that could easily be made out of materials that were found in Mexico. Korea, of course, has a great example, beautiful example, the iPhone sausage stylus. Sausage is amazing, I think. Jogar. The Indians call it jogar. So this next project I want to talk to you about is, I think my opportunity to do a jogar, an appropriate technology. Not to say I did it alone. I didn't. I just did a small part of it. But the project starts with this man. His name's Tony. But on the streets, he calls himself Tempt. He was a graffiti artist. Still is a graffiti artist, living in Los Angeles, California. And he was quite innovative for his style and for where he painted graffiti. And he did so all the way up until the early 2000s. And then suddenly he got sick. He was diagnosed with a disease called ALS, so also known as Lou Gehrig's disease. It's a neuromuscular condition. It strikes your whole body, starting with your brain, and causes full body paralysis. So, you can't move your legs, and you can't move your arms, and you can't digest food, and you can't talk. Eventually, you can't breathe. So right now, Tony's living on a respirator. A machine keeps his lungs breathing. And, we'd never heard of Tony. But we met a guy who had. His name was Mick Ebling. And he runs a production company in Los Angeles. And Mick said, hey, I saw that graffiti research lab stuff. You guys do that laser tag. I have a friend. He can't do graffiti anymore because he's paralyzed. Maybe you could hook that laser up to his mind or something, and he could, draw with it. And we were thinking, probably we couldn't do that, actually. We said, but, what has he got? What can he do? He said, well, he can't do anything except think, just like all of us. Oh, and he can move his eyes. And we were like, oh, we know some guys. So me and Evan, we called up 3 people, 3 best programmers we know. They started a project called Open Frameworks, which is programming for artists. And they work with us often in the Fat Lab. Zach Lieberman, he was one of the founders of Open Frameworks, a very good programming teacher, taught a lot of people how to program that we know. Chris Sergru, she did her thesis in eye tracking at Parsons. She's a designer, but she studied computer science for its artistic purposes. And a guy named Theo Watson, he was our friend who actually wrote the laser tag software. And we called them up and we said, okay, we met this guy, he wants us to come to LA, there's absolutely no money in it, but it sounds really hard. And they were like, okay, we're there. And so we met up with all Tony's friends, his extended family, and we started working on trying to find a way to solve the problem of how do you give someone the ability to draw if all they have is the use of just their eyes. 6 muscles on each eye. What can they do with that?
Oh, we're at the Alhambra Medical Center here in Alhambra.
So, on the video here, you're listening to, very quietly, Tony Kwan's father talking. And Ron, he's talking about Tony's condition. Tony can't move. He can't talk. He can't breathe. But his mind is still totally alert. And so, using that as our inspiration, we started designing. We had approximately $250 US to explore this idea of creating an eye tracking system that had the potential to draw. And it seemed quite easy, to get the thing that kept that camera pointed at your eye. We just went to Venice Beach and we bought some sunglasses. So that was like $2. We put that on. It took a long time to find the camera. I think maybe Zach found that Sony PlayStation had this really cool camera called the PS3 iCam. And it was really nice because you could just plug it right into your computer. It had open source drivers that some other really cool otaku person had made for us. And if we plugged it in and we kind of manipulated the camera a little bit, took out the lens, because we followed some instruction sets on a website called Open Eyes, then we could make a kind of an eye tracking system, a very simple one, but it would work. And then the hard part was the software. So Chris and Zach and Theo programmed and programmed and programmed and programmed until they came up with a kind of a software package that's a little bit like Illustrator. Do you know Illustrator? It's like a vector-based. You stare at a point, and then you drag a line, you make another point, and then you do that to make a shape, and you can fill that shape with colors. You can make your lines different colors. You can extrude that to create 3D shapes. And then we put it in Tony's hands. When we used it, it looked kind of bad. But when Tony used it, it looked amazing. And he could make drawings with it right away. But he said, what I want to do is I want to make work outside again. So we thought, let's just take all the equipment we use for laser tag and hook it up to the iWriter system and then go and project. And so one night in Los Angeles, California, with Ron, Tony's father, standing by our side, and Tony in a hospital room somewhere in Alhambra, we did it. He was able to draw again for the first time in 5 years and watch his graffiti be created on a street in Los Angeles, California, where he used to paint with his hands, It's quite a touching project for us. And it continues. So my colleague Evan, he made a software data file, like XML, but it's called GML, Graffiti Markup Language. And so you can export Tony's drawing data, and you can send it to machines like, paintball guns or robotic arms or something. And you can also project it in public space. And so, it went from 20,000 US dollars down to 40 bucks. That was the end cost. And this is my first drawing. It's not too good. That's Tony's first drawing. And here's the types of things Tony makes today. Quite beautiful things. He's created his own font called the iWriter font. I've been using it in this presentation. He's shown his work at the Getty Museum. It's not that he just became a functioning artist again. It's that he became a functioning commercial artist again. And from his hospital room, he's the kind of leading figure in a movement to provide low-cost alternative technology for people who have, full body paralysis. And then now at Parsons, it continues the development in an open source way. So the project, we all went back to our own homes, and Zach Lieberman went back to New York, and he started teaching a class in the iWriter. And a group of people in that class, especially a young man named Ito from Japan, he created an iWriter 2.0 system that's much more technologically advanced. And it costs about $200, but is comparable to existing eye tracking technologies for communication. So, I just want to end by saying, I really like this quote from Jean-Paul Sartre, where he says, freedom is what you do with what's been done to you. We didn't make this world. And certainly most of in this room didn't make those problems we all have today. And Tony didn't make himself paralyzed, What defines us is what we do to define our own freedom within those limitations that we've been given. And probably, if we do it all together, it'll be a little bit easier. 감사합니다.